All right, number.
Yeah.
Yep. So we have here factorize completely each of the following expressions. All right. So to factor this, we need to find this HCF, highest common factor. Okay, HCF. So we take in x, y squared. I like to do like this. XY squared there are a few ways we could write this, but I'll just write it as x multiplied by y, because the y squared is y by y. And then we also have, I'll take the negative sign, definitely. So negative x squared y. This can be written as negative x by positive x by y. Now, what do they have in common, both of them? Both of them have at least one positive x in common, so that will be part of their HCF. And they also have at least one positive y in common, so that will also be a part of their HCF. They don't have anything else in common, so the HCF for factorizing here is xy, open brackets. What do we need to multiply xy, sorry, by to get back xy squared? Well, what remained? The only thing that was not
Why?
a part of it, yep, correct. So y, what do we need to multiply xy
Close
by again?
bracket.
What did you say?
Then I close any bracket and then put take away and put xy by in bracket x.
Take away x. So x, y take away x, and that is a factorization here. If any of you have questions about it, you know what to do. Make sure to ask your questions because I'm about to clear the screen and move on again. Good afternoon, Natalia. Okay, so I'm clearing the screen then. The next part, so we have 3x squared plus x minus 10. So we have a quadratic expression. They said factorize. So we have to use the factorization method here. Um, so that means we need to identify, okay, what is A?
A is 3,
Thank you. What is B?
1
Thank you. What is C?
minus 10.
Good. And what is AC?
AC equal minus 30.
30. Whoo! Is it a negative 30, meaning A multiplied by C? 3 by negative 10? I think you know what you're saying, but I'm not sure if you just told me the wrong thing in error or something. But yeah. Negative 30, okay? So we need two numbers. And when those two numbers are multiplied, we must get AC, which is negative 30. And the same two numbers, when we add them, or we put an addition sign between them, we must get B, which is positive one. Mhm. In
Negative 5 by 6 give you a negative 30. Negative 5 and 6 give you 1.
I see. Very good. Is there anybody who lost with that? I don't think so. But is there anybody who didn't get that or who didn't do it at all?
Miss, I
Mm.
didn't get that.
Oh, okay. So what you needed to do, normally you want to look at pairs of numbers that could multiply and give you 30. So some pairs will be 1 by 30 will give you 30. 2 by 15 will also give you 30. 3 by 10 will give you 30. 4 by nothing, 5 by 6. So it's like you're looking for numbers, factors of 30, right? Which are all the numbers that can divide by 30 without a remainder. That's what we have on the screen here. But I have them in pairs. So all of these can give you 30. Now, in order to get negative 30, one number must be negative, like a minus by a plus and a minus. That's the only time you get an answer to be negative. One number has to be positive, one has to be negative. So now we have to decide which one has to be negative in order for us to get negative 30. Well, it doesn't matter, honestly. Any one of these can be negative and we still get negative 30. But the key is to really choose the right pair is when you add in them. Which pair? If you were to take them away, you'll get anything like number one. If you say 30 take away one, you never get one. You get 29. If you say 15 take away two, you get like 30. If you say 10 take away three, you get like 7. If you say 6 take away 5, you get 1. So that would have been like the key there. It has to be the pair with 5 and 6. But now then you have to identify which one of those two numbers needs to be negative. Because if 5 is negative and 6 is positive, or if 6 is negative and 5 is positive, and you multiply them, you still get negative 30. But the one to decide which one will give you positive 1, which is B, the value of B, normally that's the rule with when you have a negative and a positive number, right? Um, in order for your answer to be positive, such as positive 1, the bigger number has to be positive. If the bigger number, which is 6 in this case, is negative, the answer will not be positive, it will be negative because the answer always takes the sign of the bigger number. Okay, so 6 take away 5 is 1, and because 6 is positive, 1 is going to be positive. So yes, the correct pair is -5, positive 6. So I hope that's clear. So continuing then, so we open some brackets here. What we can do, they didn't tell us to factorize completely, right? But normally, because we have a number in front of x squared, in one bracket, we have to put 3x, and in the other bracket, we put x. Because if we were to undo these brackets by multiplying, x by x will give us back the x squared, and 3 by what's supposed to be 1 here, because there's no number, so it's 1, right? We'll give back 3. If we didn't have a 3 in here and it was just x, you just put one x in each bracket. But when there's a number in front of x in one bracket, you have to put the x with the number. The next bracket, you put an x by itself. Okay? And we put in the two numbers. It doesn't matter which one you put in which bracket, right? You can put -5 in the first one or in the second. But wherever you put -5, positive 6 will go in the other bracket. And that's just now. We don't have to do nothing else here pretty much. Let me just make sure, right? Let me just double check something here. I have to be careful, so I'm just double checking to make sure, because that will give us back the 3x squared, right? If I multiply that by 18, I multiply that. Okay, so we want to do it a little different, right? The reason why when I'm multiplying in my head, I'm getting back some of these terms, but I'm not getting all of them. So what I'll do to make sure it's correct, instead of doing it that way, that's because it has the 3 here, right? I will do it the longer way, which is put back the 3x squared, and we're replacing the x here with 5, but you have to write it as a term in x because we're replacing x. And the 6 as well, but as a term in x. Yeah, because if I do it the other way, I'm not getting back all the numbers. Okay, so I just replace that there, and then I'll put them in brackets. I'll put this in a bracket, put that in a bracket. Uh, what we can do next is factor out the brackets. Yeah, so that's the best way to do it to avoid making an error. So taking the first bracket, which is 3x squared minus 5x. Okay, don't write it like that. Let me write them separately, sorry, so I could expand them separately. So this one is 3 by x squares, x by x. The other one is negative 5 by x. What do they have in common? So we're looking for the HCF, highest common factor. They have an x in common. So that's the only thing they have in common, apparently. Because I'm not getting nothing else in common. Okay, so mm, we put x here, and what x has to be multiplied to get back this? X by 3x, and then what didn't have in common for this next one is negative 5. I hope you all are clear, right? So what I just put here is what I did not include in the HCF. So if I had to remove this bracket, if I multiply x by 3x, I must get back 3x squared. If I multiply this x by negative 5, I'll get back negative 5x. So this is correct thus far. The next part, or the next bracket is, we have 6x and we also have negative 10. This could be written as, well, it's an even number. So 10 and 6 will have at least 2 in common. So I could write this, I could have written it as 6 by x, but then these two would not end up with nothing in common. So that's why I'm writing it as 2 by 3 by x, so that I could also write 10 with 2 in it. So I'll put the 2 positives to keep these 2 positive. 2 by negative 5 will give me negative 10. So now they'll have something in common, which is the number 2. So their HCF is 2, which is positive, of course. So here we put plus 2 because we continue the question. Open bracket. Well, you have to multiply 2 by to get back. Why put 10 there? Sorry, that not supposed to be 10. That should be x. Why did I write 10 there? So this should be x. 2 by 3x would give us back 6x. And 2 by negative 5 will give us back negative 10. So the key when we do this like this, we must get the same thing in brackets twice, and we did. So we have 3x minus 5 twice. So then we would write that bracket once. We drop one bracket and we write it once. And what's outside, which is this x here, we put that in a bracket with this other number plus 2. And yeah, that's the end of this. So that's the correct thing, okay? If anybody have questions, ask your questions.
Miss, I now get that part.
Okay, no problem.
That's with you, and now with myself. I was you.
Okay, I see. All right. So I am going to clear the screen again and move on. All right, so we have this question there, and it states, so for n, we have 4 to the power of n divided by 4 to the power of 3 is equal to 1 over 4. So what they want is find n, right? Okay. So what we want to do here, before I even start solving for n, I need to or I want to actually write this fraction in the same form as these indices. So change the fractions and indices, right? There is a goodness. There's a rule in math, right? If you have a to the power of negative n, this can be written as 1 over a to the power of n. So what does this have to do with that? A lot of stuff. Because this fraction, right? 1/4 is actually 1 over 4 to the power of 1. Because it's a 1 power, they don't write the power. Okay? But if I was to convert this to that, what we do, the base number here comes the main number here. So this 4 here becomes 4 here. And the power that is here becomes negative, right? The power that is here becomes negative. So 1/4 can be written as 4 to the power of negative 1. So I'm rewriting the question as 4 to the power of n, sorry, divided by 4 to the power of 3 is equal to 4 to the power of negative 1. So since everything now is in the same form, everything is in indices form, I know that when you are dividing powers or indices, you subtract the powers. So, in other words, this could be written as, this stuff here could be written as 4 to the power of n take away 3. And based on what we have here, we already have the answer. This will result in negative 1. So what we can do, we can take this to the side and work it out by itself and transpose for n. So n minus 3 is equal to negative 1. To get n by itself, we need to move the negative 3. To move a negative number or power in this case, same thing you'll do. You add the number, you do the inverse of the sign in front of the 3, so you add it. And like you would do in any normal transposition question. If you add something on one side, you can add it on the other side also. So this becomes 0. The unit of n is equal to negative 1. Add 3 is the same as 3 take away 1. So that means n has to be 2. So the power n that they want there is 2. So again, I hope you look good. I'm looking to move on. Okay. All right then. So I'm going to clear the screen. Clear the screen and continue. All right. Says here the length of 3 sides of a trapezium is shown on the diagram below. The area of the trapezium is 750 square units. Write down an expression in terms of P and Q for the area of the trapezium. Area of the trapezium, they want an expression. Okay, so area of a trapezium is okay, I could do it here. A half by the sum of the parallel sides AB by the height. So the height is here, right? The height is always perpendicular. That's why we have 90 degrees. The height is perpendicular to the parallel side. So the parallel sides are 4P. So this here will be the parallel side. Okay, this is one, this is the next one. The reason why I'm drawing those lines so long is to show you all parallel sides. It doesn't matter how long you extend them, they will never meet. Okay, so it doesn't matter which side you label as A nor B, just label one as A, label the other as B. And if you're wondering why, it's because you have to add A and B. And addition, it don't matter which number you put first or second when you add in. if you add in two numbers, two or more numbers, you still get the same thing. It don't matter which order you put them in. So that's why you could put A here, B here, or B here. Oh, sorry, A here or B. It don't matter, right? So using this information, let's create the expression we want. So half A I label as 4P, B I label as 3Q. Wow, okay. The height is 6P. Some interesting things. Now, we can't even add what's in the bracket because we have two different terms. We have a term in P, we have a term in Q. You can't add a term in P to a term in Q. Now, if both of them were P's or Q's, yeah. But what I have to do then, I have to distribute. I think I'll start my distribution from the front. Yeah. From left to right. So a half multiplied by 4p. A half of 4 is 2, right? Half of 4 is 2. So that become 2p. Half of 3 is 1.5. 1.5, 1.5q. And we still have outside the other side of the bracket 6p. In case you are wondering, right? Anytime you do not see a sign between a bracket and a number or a bracket and a letter, they are being multiplied, right? So that's why I'm multiplying these things here. And I have to multiply this as well. So now I'm going to distribute the 6p to the 2p. Sorry, so 6p multiplied by 2p, 6 2s are 12, p by p is p squared. If anybody don't understand that, let me know, but actually I'll do it. P by P, both of them are actually to the power of 1. When you're multiplying the same letters, you add their powers. 1 add 1 is 2. What did I put it there? Sorry. 1 add 1 is 2. Okay. And same 6P by 1.5Q. 1.5 by 6 is what? I think that's 3. I'm not sure, so let me use the calculator. 1.5 by 6. I don't think it's 3, it might be 4 or
9.
something. 9,
Yeah, that way saying 1.5 by 6 equal 9.
I guess. Okay, yeah, thank you. So 9, uh, Q by P is QP, PQ. It don't matter which letter you put first, just put the two letters. Yeah, so that will be the
You
expression.
can put back the six.
Pardon me?
You put back 6.
You put back six.
Upper box 6? Oh,
Mm.
sorry. What is going on with me? What is going on with me? Thank you. Yeah. So we have 9PQ. So that's the expression. Who is marking on my screen? That's the expression they want to be, okay? All of that work for 1 mark, really. All right. Excuse me. So the next part, I'm clearing the screen, or do I need this expression? That's all. Let me don't clear as yet because it have another part here. So it's given that Q is equal to 2P. Q is equal to 2 multiplied by P to determine the value of P. Oh, I remember this question. This question is a simultaneous kind of thing going on here. Okay, so what I'll do, what method should I use? This here is already by itself, so the only method I can use is substitution. I can't use elimination at all. Now, if you're wondering why, well, um, it's a determined that the reason why, is there something else they give us in this question? Yes, they did. It said the area of the trapezium is 750. Oh, so they give us the answer for the area. So what I'll do, I'll put this equal to 750 because we're going to need this. Because if you do not simultaneous equation, you need answers. You need the full equation. You can't just use an expression. It's not going to work. Okay, so taking off this, taking off that. Um, 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 let's see here. Now, if you're wondering, how do I know this is a simultaneous equation? Well, let's start to find P, right? What does the equation have? It has Q and it has P. I'll tell you something. Anytime an equation has two letters, two different letters, you cannot find the letter they ask you for with one equation. The only time we could find a letter, the value of a letter in an equation is when that letter is the only letter in the equation. Or even if you had, let's say if we had like P is equal to 2P, yeah, because you have P's, both of them are P's, so you just transfer to the P's and figure it out. But when you have two or more different letters, the only how you could solve for one of those letters is simultaneous equation. So that's how I know it's simultaneous. Because unless they would have said, okay, given that Q is equal to 10, if they give us a value of Q in the question and said Q is equal to 10, use Q equal to 2P and find P, yeah, because we know the value of Q. We could find it without using simultaneous, but they haven't give us Q, so only thing we could do is simultaneous equation. Now, the reason why I said substitution method is because in order to use elimination method, um, elimination, you normally need, you see how we see no kind of weird thing going on here? I call it weird, but you see in PQ and you have a term in PQ, you have a term in um P squared. You have a term in P, like you have a whole set of different terms. You can't do no elimination without elimination requires that you have either both of them must have a P and the P must have the same number in front of it, the same coefficient, or both of them must have a Q, a term in Q, and the same number in front of the Q. None of that is going on here, so you cannot use elimination. So it's substitution for sure. So here's what I'm going to do. Let me write this on top here so I can begin the working. Okay, that's supposed to be P squared, right? Just write that properly. P squared plus 9PQ equal to 750. What are we going to do next? Yeah, so using this here, we're going to substitute. Wherever we see wherever we see the Q, there's only one Q in here. We are going to replace that Q with 2P because that's what Q is equal to. It is equal to 2P. So we are going to remove this and replace it with 2P. But always remember, right? 9PQ is actually being multiplied here. So you don't want to just write that in like that. You want to bear in mind we have 9 by P by Q. So since we're going to replace the Q, we have to multiply this by 2P. So here we go. Here we go. Here we go. So I'm rewriting this as we have that there. That is not changing. And then what's the next thing? Plus 9. We have the P. And we are changing the Q. So if you want to put it in bracket, you can put it in brackets, is equal to 750. Okay. All right. So now we could do some form of simplification here. We have to simplify. Uh, if we multiply 9P by 2p, what do we get? 9 twos are 18, okay. P by p is p squared. Interesting. Put back the plus p squared.
Means
Okay.
is that 18? Or 9 multiplied by 3, 2p.
Correct. Yep. Okay. So we have terms in p squared. Both of them have a p and a squared. So according to algebra, you can add or take away their coefficients. Their coefficients are 12 and 18. So 12 and 18 is 30. And because we added terms in p squared, we put back the p squared is equal to 750. Okay, 30 p squared means 30 multiplied by p squared. So we need to get rid of the 30 before we can get rid of the squared. And if you're wondering why, really and truly at this moment, as of right now, I am transposing from this line. Before I was not transposing, but now I am in the process of transposing. So by transposing, there's nothing subtracting, nothing adding. There is something multiplying, which is 30 to be multiplied to the p squared. So I move the 30 first by dividing, doing the inverse of multiplication. Okay, 13 to 31, even as with p squared is equal to, hello calculator, I got some work for you. Take away, not take away, divided by, okay, I got 25. Looking good thus far. And there's nothing dividing, but there's a power. There's an exponent right over here. To get rid of a power, you find the square root, right? The square root will cancel out the two. Do the same thing on the other side to keep your equation equal. So we find the square root of 25, 5 out of 25. So the square root of 25 is 5, and the square root of p squared is p. So the value of p is 5. I know this might have been for some of you like, what is this question, eh? But I hope you'll understand. And if anybody have any questions, oh,
But they explain it nice.
okay, I'm glad that I did. So, thank you. I'm going to clear the screen if nobody's writing. And